All right, let's take a look at number 3 now. Once again, I need to go ahead and identify what the parent function is. So my graph looks like it's a straight line. That means it would be a linear function. And now I need to identify what exactly the transformation is. So this has a scale of 2, which means if I want to graph my original function, the point 1, 1 would be halfway in between here and halfway in between here. So here's 1, 1. I'm going to put one more point at -1, -1, just so I can get a better picture of what's going on. So here's my parent function. Well, it doesn't appear it's moved up or down, left or right, so it's not a translation. I wouldn't say that the graph is necessarily flipped, because then there would be a point here and a point here. So it's not a reflection, which means it's either a stretch or a compression. It does look like this new line is growing at a much faster rate than this one is. So I would say it's a stretch. Another way we can think about it is if I take a look at this value in front of the x, that's my a. So a is 3. A is clearly greater than 1 then. And remember, the criteria for a stretch is that a is greater than 1. All right, domain and range. This linear function is going to go on forever. Okay, there's no restrictions, nothing stopping it, no max, no min, nothing, no starting point. So as it moves left, it's going to keep being defined. As it moves right, the graph is going to keep being defined. Even as it moves up or down, it's going to keep being defined. So really, the domain and range is going to be the same for this. It's going to be all real numbers for both of them. So you can either write it using this notation, or you could even write it this way. I'm going to leave that up to you. I'll accept both. Both are good. I'm going to continue doing the odds, so taking a look at number 5. Now, this shape right here indicates a square root function. We can even look at the graph or the equation and see that there's a square root there. And when I think about, let me write this real quick, square root. When I think about the transformation, I need to keep in mind what the original parent function looked like. Well, originally, there's a point at 0, 0 and 1, 1. So originally it would look like this. It doesn't appear it's moved left, right, up, or down, so there's no translation. But you can tell that the graph has been flipped. So that, remember, is what we call a reflection. And if I'm looking at the equation, if you ask yourself what would cause that to happen, well, that would be that negative out front there. Okay? So, domain and range. Since there's a starting point, at this case, at 0, 0, and we need to look at our new graph, not the parent function. So I'm looking at this graph right here. For domain, I need to look left to right. So the furthest left this function goes is right here at the point 0, 0. And because I'm looking at domain, I need to check the x value of my starting point, which in this case is 0. It's included, so I need to put a bracket. Now, as this function moves to the right, it's going to keep going and going and going. Because remember, I mentioned a square root function has a starting point and extends forever in one direction. So this is actually approaching positive infinity because it's along the positive x-axis. And I would need a parenthesis there because infinity is not something that we can ever reach. Range, remember, range must always be read down to up. So as it's going down, there really is no minimum. It's going to keep going and going and going. And because that's a down movement, it's actually approaching negative infinity because we're along the negative y-axis. So negative infinity, which would use a parenthesis. And then I need to look at the top of the graph. So as the function moves up, well, the highest point of this graph is actually here at 0, 0 once again. So the y value, because it's range, the y value is 0, and that is included, meaning I would need a bracket. I'm going to go ahead and pause this video. I would like you to try the evens and hit play when you are ready. Hopefully you attempting the evens went well. I'm going to start off with number 2 here. So as I'm looking at the graph, or even the equation, because the equation can be helpful, I can see that this is a cubic function. Okay, I can tell by the shape, or there's a power of 3. So this is a cubic equation, and I went ahead and graphed the parent function. It appears it's moved up 1 unit. So if I look at the equation, we can see we were adding 1 on the outside. So that could account for that movement, that translation. Domain and range were both all real numbers because as we move left and right, the function will always be defined. As we move down or up, it will always be defined. It continues forever. Number 4, again, use the graph and the equation to help you. This is a linear function. There's a power of 1 on that x. That's what caused that linear shape. And there was a compression here. It's easier to tell if you graph that parent function, being mindful of the scale of 2. We can see that this new function is moving at a much slower rate. Okay? What could have caused this compression is the a value. A is 1/2, and that is between 0 and 1, which remember is what we said would classify it as a compression. Domain and range are all real numbers. Same reasoning as when I did number 3, so rewind and hear that explanation again if you need to, but I'm going to move on. Number 6, this is a parabola, so I know it's a quadratic function. Also, if I was looking at the equation, I can see the 2 for the power. Transformations, I moved left 4 and down 2. So in number 1, there was a -6 and we moved right within the parentheses, but now notice when we're again still in the parentheses, but now it's a plus, we're moving left. So normally you would think, -6 moves it right and +4 moves it left. Why is that? Well, we're going to talk about that on the next page here. And then there was also a -2 on the outside, so outside of that parentheses, and notice how it moved down too. Domain and range, the domain was all real numbers because as we move left and right, it will always be defined. So we didn't end up needing to use that -4 at all in the minimum. But we did need to use the -2, which is the y value in the range. Remember, it's always down to up. The lowest y value is -2, and it's included, so I put the bracket. And it's going up towards positive infinity, which is a parenthesis, because we cannot actually reach that. I was hoping on the last few examples that you would start making a connection between looking at the graph of something and looking at the equation. So there are actually general equations that we can write. A linear equation, we've already discussed that, so I'm not really going to go over that, but I will say linear equations, x is to the first power. Quadratic, x is to the second power. Cubic, it's cubed. Square root, obviously, will have a square root. Now, I want you to notice for the quadratic, cubic, and square root, the general equation looks pretty similar. We always have an a on the outside, so that's some constant, some number, which can cause a few different things. We're going to talk about that here soon. There's always going to be an h that's associated with the power, so it's either going to be in parentheses or underneath the square root, which is also called a radical. And then you can also have plus k on the outside. So let's talk about what all of this has done. Again, hopefully you're making observations on the last few examples that we've been looking at. I want to start off talking about A. So A is that number out front. It can tell us a couple of different things about the equations. First off, it can tell us if there is a reflection. So remember, a reflection is when a graph is flipped. We're going to stick to reflecting it about the x-axis, and this is going to occur when A is negative. Okay? If A is positive, there is no reflection. Next, the A value can also tell us if there is a stretch or a compression. If it's going to be a stretch, remember A is going to be greater than 1. If it's a compression, it's going to be between 0 and 1. The H value tells us if there is a horizontal transformation. So that means moving left or right. So that H value will be found within parentheses or underneath the root. So it's always going to be associated with that power. But we mentioned a little bit on the previous examples, if it looks like x minus 4 squared versus, let's say, x plus 2 squared. Because it's the form x minus h, here h is actually positive, a positive 4, because we're subtracting a positive number to get this expression. And when h is positive, a positive movement would be moving it right. Again, because it is, oops, there we go. Because it is x minus a number, if you have an expression x plus 2, we're actually having to subtract a negative 2. So h is negative 2 here, and that's a negative movement, meaning we move left. Lastly, the k value, so this is always on the outside. That just tells us if we're moving up or down. This one's pretty straightforward. If it's plus k, we're going to move up. If it's minus k, so we're subtracting some number, we're going to be moving down. Keeping this in mind, we're going to try to identify the transformations just by looking at the equation. We're not going to graph it on Desmos. We're not going to do anything like that, but just take a look at this and see if you can write down what type of transformation will occur using these notes. Go ahead and pause the video, attempt that, and we'll come back together here in a moment. Okay, really quick, because I'm running out of time, I want you to take a look at my work. I wrote all the explanations. So check over that. I just want to go over really quick though, number 7. A lot of times people see a fraction and automatically think compression, but make sure you're looking at the value. 3/2 is equivalent to 1.5 or 1.5, which is actually greater than 1. So it should have been a stretch there. Hopefully that didn't get you. I do want to ask after you check this and before you start your homework for tonight, can you please make sure that you download the Desmos app? That's an online graphing calculator. It's free. You're going to need it for your homework tonight, and we'll be using it a lot throughout the school year. Have a great day, guys.